Next up, Professor Alexander Aptekar again, with this time with his students' projects for the Department of Energy. Very exciting work. Thank you.
Hi, and welcome. I'm really proud of this group of students, some of which will be presenting today, and what they've done mostly as an extracurricular activity is to think through how to design and build a zero energy house, one that has a chance of getting created. And they did this with a lot of training from the department, well, some training from the Department of Energy, and a lot of teamwork and a lot of sweat and thinking through not just how to solve things in their area of expertise, but also going outside their comfort zone to look at other systems that usually most of them are architects. Usually architects don't look at to make this house function. So I believe we have 3 of our team members here, and they're going to present the project. First, this is our first slide, and welcome you to start this presentation. And we're hoping to answer any questions if we have time at the end. So please, if you have any questions, we'll do our best to answer them.
Thank you, Professor. Thank you for the effort you put into presenting this project. Hello, everybody. This is Tim Dura, and we're presenting for the New York City College of Technology. We presented for the Solar Decathlon 2021. This project was organized as an extracurricular research. The site location is Colchester, Essex, in the United Kingdom. The feedback received from the Colchester Board and Construction is set to begin in July with a budget lower than the average house in the neighborhood. 24 solar panels was used to attain the amount of energy needed to power this house through the southern sun exposure. A locally available material called straw bale was used in the lower unit and double stud construction. After a lot of research was done on the building codes and standards, more ambitious standards were applied to the project. In creating a net zero and passive house was the main performance goal, so every other goal was in relation to that. The design goals had to do with different wall assemblies that were integrated performance with the building systems and having low carbon, embodied carbon with synergetic solar generation, and make sure to design for dual living. Some of our technical specifications included a heat recovery ventilator and hybrid solar panels. For the architecture of this house, we made sure to make use of the combination of wood and fiber cement panel finishes and the exterior to give it a clean look. Both levels contained a double stud wall assembly, which was durable and has a high R value assembly. The integrated systems were designed to support each other, such as the sunroom will be designed as a thermal mass to reduce the heat and load, as well as provide daylight through the clerestory windows. The occupant experience for most aspects of the home were made to be smart controlled and have digital user interfaces to facilitate the usage. We made sure to include the details, and we had a lot more details while presenting. The embodied carbon energy. In this, we use building construction materials, including embedded energy, it is one of the leading sources of carbon emissions. 11% according to the UN. To address the embedded energy impact of our building, we're looking towards using materials known as sequester carbon or stored carbon, as it is not in the atmosphere, including straw bale. Our project is designed to limit or eliminate the use of high embedded carbon materials, concrete, steel, and aluminum. Our project is intended to encourage the use of straw bale as the building material because of its ability to sequester or store carbon. Straw bales are typically 40% carbon by weight. In our project, its carbon impact will be reduced because it's local material and it will take very little energy to move it to our site. In our details, we have replaced as much concrete as possible and with crushed gravel. Replacing concrete with gravel will drastically reduce our project carbon footprint, as carbon is responsible for approximately 10% of the global carbon CO2 emissions. Most of the embedded energy in concrete during its manufacture and our crushed gravel, this thus avoids the embedded carbon input.
Good evening, everyone. My name is Erickson, and I'm a third-year student. I was working on the engineering aspects of the home, and I'll be presenting you some of the different areas of engineering. So first off, because our goal of the home is to be zero energy, we had decided to choose hybrid collectors that provide both electricity and thermal heating. They produce around 39.6 kilowatt hours, running 5 hours a day of energy. And they were placed at 53 degrees for optimal efficiency. I can go to the next one. And then serving as the second system for our heating of the home and cooling as well, we have a hybrid ground source heat pump that can be connected to the solar panels. And then by connecting to the solar panels, it allows us to reduce the time that we run the heat pump, which means we're using less energy. And then what's great about this heat pump as well is that we don't have to do extra digging or doing a lot of preparations because this is very compact, and it also has a lot of smart controls, which makes it very feasible and very easily manipulated and used by the user in the home. Next. For our gray water system, it basically serves as a once-use water system, and that means that we can reuse waters, for example, such as dishwater or any other gray water of the home, and reuse it to use it for the garden or any other sort of ecosystem that you have outside of the home without having to waste that water and using fresh water. We can go to the next one. And then for the plumbing, we just basically tried to explore the most direct lines from our tanks, our supply tanks, to our sinks and bathrooms and other areas of the home that are using different, I guess you could say, a different type of like faucets or just any plumbing in general. The straight lines reduce the wait time as well. And then because once again, we're trying to minimize waste, as much waste as possible, we have a lot of limiters on our sinks, and then we have it on our tubs, and those limiters place a limit on how much water runs through those pipes, which means that we're reducing the amount of water we're wasting. Next. Yep. And then for comfort and environmental quality, our standard is to be both efficient with the heating and cooling systems of the home. So we implemented systems that range from as I stated earlier, the heat pump to HRV systems to a triple glazed windows, which helps us maintain the passive house standards and keep a heated home during the summer and cool home during the winter as well. And then you can go to the next. And then this is a simple diagram of our HRV system. Our systems are supplying fresh airs to the bedroom and living spaces, and we're exhausting waste air from bathroom and kitchen to maximize the efficiency and air quality of the home. And that's for engineering.
Okay, so good afternoon. I'm Tasfia Amir. I'm a fourth-year student and also in the BR program. So I'm going to talk about the durability and resilience. So from our research, we found that because of our location, our site has no risk of getting flooded in the upcoming 100 years and not much of risk of any severe earthquake in this area. However, there is a possibility of temperature increase in the future. And another concern is blackouts, which is a very common scenario during any natural disaster. Next. So like we've mentioned, our heating pumps with the cooling system, it can provide the comfort during hot summer when the area goes through heat waves. And we can use the app, the Vicar app, to control our heating system. And the heat recovery system will transfer cool, fresh air from the outside into the home. So occupants are able to adjust the HRV system's humidity control ability through a cloud-based control system to maintain the humidity level during the summer and winter. Next. And if there is a supply outage due to any disaster event, we can use our smart grid system to provide the necessary electricity during those times. So we have specified Powerwall 3 battery systems with 4 kilowatt capacity for our project. Some of the unused energy from the solar panels and off-peak electricity from the grid will be stored in the battery system, and it can save occupants' energy bills. And customers can use the Powerwall customer portal to monitor their energy use and optimize their battery charging schedule. And we'll put the plugs outside our property that is part of the charging system so that the people from the neighborhood can get access to this when necessary. And our project also includes an electric vehicle charging station. So we are using Nissan Leaf S Plus electric vehicle with a 62 kilowatt-hour battery and a quick charge port of 100 kilowatts for our project. So it uses the vehicle to grid charging technology, which allows it to act as an additional battery for the smart grid. And also there is a 3-pin charging cable connection port that is provided as a backup charging option to increase the project's resiliency. The car charging system can utilize on-site renewable energy and the battery and smart grid systems to its maximum efficiency. Next. And our sunroom, it acts as a thermal mass and reduces the amount of heat energy needed to maintain the interior temperature. So it acts as a temperature storage during a power outage. And also our double stud wall and the straw wall, they have high R value. So it's an excellent thermal resistance for both wall systems. And our wall assembly includes a continuous smart air barrier that was designed to open up in dry conditions to become more porous and let the moisture in the wood frame dry out. And their permeability is low during the winter and high during the summer when the humidity is higher. And for the straw bale wall assembly, the straw bale is really dense and the stucco is so airtight that it successfully deals with the moisture. And our straw bale wall with a gypsum finish remains vapor permeable, so it lets the vapor easily move through the wall. Next. So next I'm going to talk about the energy performance. So our doors and windows, they both meet the passive house standards and they have a low U value, which means they're more resistant to heat flow and more efficient. Next. And like I've already mentioned, our Powerwall 3 battery is capable of storing extra solar power and discharging back to the grid when needed. But also our battery comes with the cloud-based intelligence GridFlex platform that will allow the occupants to maximize energy efficiency by adding flexibility to power generation, usage, and grid connectivity. It will allow to relieve the potential stresses and enhance grid reliability. And then we are dealing with plug loads by adding switches in our rooms that can also turn off outlets. So if we leave something charged, it will turn them off. And for appliance loads, we are specifying all high-rated appliances. So all of our appliances have a rating of an A++ by the European Union Energy Labels. It means that our appliances use less electricity and work more efficiently compared to similar models with lower rating. And A++ rated appliances can also reduce greenhouse gas emissions. Next. So we had a few energy models, and we wanted to compare the HARS index score. So one of our goals was to compare two different wall systems. So what we did is we had one energy model with both double stud wall and straw bale, one energy model with only straw bale, and one energy model with only double stud wall. So what we got is that our energy model with two different wall systems gave us an index score of 0. So when it comes to index score, the lower the number, the more efficient the home is. So index score of 0 means that it meets the energy, zero energy home requirements. And then our energy model with straw bale wall also gave us an index score of 0. However, the energy model with double stud wall gave us an index score of 1. So it is still efficient, but it means that the straw bale is more efficient than the double stud wall. Next. And then from our model, we saw that our annual heating and cooling demand, and then the peak heating and cooling loads meets the passive house requirements. Next. And then finally, we also wanted to compare models with and without renewable energy. So our model without renewable energy gave us an index score of 46, which is much higher than the score we got for the model with renewable energy, which was 0. So it again proves that our renewable energy sources helps us to make our house more efficient, in addition to like all the other systems that we are using for this project. So yes, that was our project for the solar decathlon competition, and thank you for listening to our presentation.
Thank you for presenting this as some of the team. Not all the team is here today, but if anybody has any questions, we're happy to address them. The solar decathlon is interesting how it's been evolving. For those people not familiar with it, it's when different universities compete to design the best project they can that's zero energy and solar powered. And it's evolved, so there's two types of competitions. One where teams design and build their projects, which is on one set of competitions, and then another one where universities just go through and do the design part of it. And in the past, we actually did once do the design and build, but this time you can see we've done the design only competition. And it was great. We competed in our group with a lot of really high-powered other institutions, but it was wonderful because all the different students from all of these collegiate institutions got to meet each other, talk, and share their experiences and their models with each other. So, I'm happy that the team has had this opportunity to share their project because they did a lot of hard work on it. And the slide presentations really don't show all the drawings and calculations and stress that they went through, but they tried to make it seamless because when they presented to the Department of Energy, they had to do it in 8 minutes, which was quite a challenge. So you saw the longer version because I believe we used a little bit more time here.
What an amazing project. Thank you, Alexander, and thank you, Tasvia, Olade, and Erickson. Do we have any questions for the team?
I think Felix had a question in the chat.
Yeah, I can repeat the question for the rest of the team as well. So Felix asked, are we planning to build it? And is it, I guess, feasible, and would it be good in our climate? So I think I can answer that. I don't really think it would be that great in our climate. This project we're experimenting with hay bale because the climate region for Colchester, they're very drought prone. So using that hay bale was very efficient in that climate. But when you introduce hay bale to New York, which is a more wet region and kind of there's a lot of rain, that kind of comes into play. So then you have to really reconsider as to what it is that you're trying to use insulation for the home. So hay bale, for example, after a while, moisture can get in and then deteriorate it. So I don't know if it's going to be as efficient as it is in Colchester. I think Professor can answer as well.
There is a chance that the project we built is actually a member of the European Parliament. Well, it was a member of the European Parliament from the Green Party that's interested in actually building this thing as a community project in Colchester. So, and there's a group of people that do hail bales there that are really interested in doing it. So yes, this project may be built, and we're hoping that it does, because one of the things we want to do is put sensors in the wall assemblies and test to see how they perform, and match up the energy modeling with the actual performance for both assemblies. That's the reason why the bottom is straw bale and the top is double stud, so we can actually compare the data pretty precisely because it's in the same location and under the same conditions.
So wonderful. I wonder if you'd like to say a few words about the Sustainable Technology Association Club, Professor Aptekar.
So I invite all City Tech students to join. We tend to meet on Fridays, and we try to do different projects that deal with technology and sustainability. We've worked with pocket parks all across New York City in the past. We've built little solar collectors and chargers, some smaller things, and we've regularly involved in the solar decathlon when we get ambitious to do that project. So, and you know, in these days of not being too social, it's nice to actually have a meeting and do something together. So don't hesitate to reach out to us. I can put the team contact info in the chat. I'll do that.
Fantastic. So you're open to new membership.
We welcome it. Absolutely.
Fantastic. Thank you all so very much. And I think it's time to move on to our next panel. But again, thank you, Alexander, Tasvia, and congratulations to you on being the video competition winner, Tasvia, and Oladu and Erickson. Thank you all.
Thank you so much.
Thank you.